Hi everyone, I'm Kathy Zip, Associate Editor of Solar Power World, and I'd like to welcome you to today's webinar, Selecting the Right Solar Racking System. We'd like to take a moment to thank PanelClaw for sponsoring today's webinar as well. Before we begin, we'll go over just a few house cleaning items. I'd like to mention that this webinar will be available after the presentation on solarpowerworldonline.com and also will be emailed to all registrants. Secondly, there'll be a question and answer session at the end of all the presentations. We encourage you to participate. You may submit your questions at any time throughout the webinar by typing them into the GoToMeeting panel, and that's on your right. Lastly, we realize that not everyone who would have liked to attend this webinar could, so we encourage everyone to tweet about key topics and discuss takeaways using the Twitter hashtag #SolarRacking. So at this time, I'd like to introduce our presenters. Today we have Seth Zimring, VP of Business Development at PanelClaw, Jeff Head, Engineering Manager, and Jeanette Brasher, Mechanical Engineer at Unirac's Commercial and Utility Group. And we also have Dr. Hans Reinheimer, Director of KB Racking's USA Division. So thank you all so much for being here with us today. And Seth is actually going to be our first presenter. Again, Seth Zimring leads PanelClaw's business development team, but he previously held positions in Pacific Gas and Electric's corporate strategy and development, emerging clean technology, and integrated resource planning organizations. He's also worked with several strategy and management consulting firms. And Seth earned an MBA in business at the University of California, Berkeley. So we're ready for you to share some of that expertise with us, Seth. So go ahead whenever you're ready.
Well, thank you for the kind introduction there. I appreciate it. So as Kathy mentioned, I'm the Vice President of Business Development here at PanelClaw, and they asked me to speak today about selecting the right ground mount system. And that's obviously a very wide topic. So given the limited time we have, I thought I'd focus us in on one segment of the market that is really not as well understood as some of the others. And hopefully I can get control of the screen here and actually move our slides along. All right. So I want to talk a little bit about landfills today, and perhaps we can go back a slide or two. So landfills are a very popular topic. It's been a hot topic really since the EPA had their Repowering America's Land initiative that came out back in 2008. And in many ways, landfills are this wonderful site for solar. They don't have any shading. They tend to be close to critical infrastructure. There's something where lots of people would love to turn it from an ugly landfill into this wonderful green resource for the community. And the challenge is that although there are at least tens of thousands of landfills out there, a huge number of them really aren't appropriate for solar, either because of how the landfill is physically constructed or due to some regulatory and other issues that are associated with them. In many ways, it's a similar situation to what we see with landfill gas, where there's lots of interest, but the real potential is actually significantly more limited. So what I want to do in the next few slides is give you a brief overview of two of the most critical issues that we like to think about when we're selecting landfills and helping our partners select landfills, and then talk about how you select a mounting system once you've identified a suitable site. So the first issue I want to talk about is one that's reasonably well understood, which is settlement. All landfills settle. It means the cap of the landfill will come down X number of feet over the course of time. And we really want to understand what degree of settlement can be expected. Less is obviously better. So there are 4 types of landfills that we tend to look for when we're thinking about good sites for solar. The first is older landfills. The data we've seen suggests that landfills can settle 10 or 20 feet in a couple years when they're first closed. And then we see a pretty precipitous decline in that settling over the course of time. So a lot of settlement right away, and then less and less. They'll still settle, and they'll tend to settle unpredictably, but they'll settle less over the course of time. So the older the landfill, the less likely it is to have major settlement issues that could create issues for a PV array you put on the site. The second type are privately operated landfills. They typically have limited land to use, and they focus on really optimizing the amount of garbage or waste they can get per cubic foot. And that means they do compaction, and that tends to lead to greater density, and the greater density of the materials you have within the landfill, the less likely they are to settle. Next issue, or next one we look for, are sanitary landfills. And the majority of landfills in the U.S. that are still open, that are municipal waste, have been converting to sanitary landfills. And really what that means is they're covered, the waste is covered with dirt each day. And that means there's more inert material inside the landfill. Many landfills today will have more dirt in them than they have actual garbage. And because you have that inert layer, it tends to be relatively well compacted, and it tends to prevent a lot of the biological and chemical reactions that can occur that lead to settlement within a landfill. The fourth type we look for are what are called C&D landfills, or construction and demolition landfills. These tend to have limited settlement associated with them because they tend to have less organic material. They'll have construction materials, so think concrete or steel, which aren't going to degrade over the course of a lifetime of a solar system on top of a landfill. So we look for these types of landfills when folks come to us and say, we've got a project. We'll ask, all right, tell us a little bit about the landfill. And we're looking at these key issues to help us understand whether or not this is going to be a viable project. The second issue we look at is around regulation. Not surprisingly, landfills are subject to significant regulatory oversight. There are lots of players that tend to get involved with a landfill, particularly once a landfill has been closed. So there are 3 things we tend to look at, or 3 key topics when we're thinking about selecting the right landfill from a regulation point of view, or helping our partners do so. The first is regulatory compliant closure. So there are lots of landfills in the U.S. that are quite old that were not, they were just simply closed without regulatory compliant closure. And when you close a landfill without the closure, when you go and try to do anything to that landfill subsequently, you will most likely have to go through regulatory compliant closure before you can build. And that process is incredibly difficult, incredibly time consuming, and can be quite expensive. So when you have a landfill that doesn't have compliant closure, it tends to be not an ideal site for a solar array. There's just too much involved in getting it from where it is today to a site that's ready to accept solar. The second thing that we look at are what repurposing restrictions are in place. Many landfills, either as part of their closure procedures or when they were originally designed, have a set of really restrictions that were put in place for after the landfill was going to be closed. So it must become a park, or X, Y, or Z can never happen. Whenever you have these types of restrictions or protections, it's really a nightmare unless they are specifically designed to allow solar to try to put a solar array on it. It takes an incredible amount of time to get through them. Not to say it's impossible, it's just to say it's not necessarily the best site. The third piece we look at is whether or not you have solar-friendly regulators. So Once a landfill has been closed, typically the state and local government really have jurisdiction. And there is a wide range of regulations that exist depending on what state you're in and what given locale within that state. For instance, in California, if you want to work on top of a landfill, there are 7 or 8 separate groups that you need to negotiate with in order to move forward on a landfill solar project. Depending on what their predisposition is to solar, really will tell you whether or not it's a good site or how much time you're going to spend arguing with regulators, trying to get them to agree to allow you to put a solar array on a landfill. These are kind of the top 2 things we look at. There are a variety of other topics, and we go through a full screening matrix. These are the 2 I want to highlight for the purpose of this call. The next thing I want to talk about are the 3 keys, once you've identified a landfill to work on, that you need to think about when you're selecting a mounting system. And they're really around load limitations, layout and drainage, and site maintenance. So first, when we think about load limitations, there's some pretty straightforward and obvious things that people think about. The first is you want something that is non-penetrating and lightweight. You don't want to get into a situation where you're puncturing the landfill's cap. If you have to do that, it tends to be a regulatory nightmare. You have to deal with a whole number of regulatory authorities to get permission to do so, and often they'll deny it. And then on the light side of the house, you want to avoid damaging anything that's buried underneath. And specifically what we're really thinking about there is piping and some of the other infrastructure that's used for gas wells underneath a cap on a given landfill. The next issue is again around weight, so that you want to install without heavy equipment. What we find is landfill caps tend to have weight limits. Typically what we see is 854 PSF is the typical limit that you'll have on a regulatory compliant closure cap. And that sounds like a lot relative to what a system might weigh. But when you think about, for instance, bringing in large pieces of ballast on a truck or bringing in large construction equipment, the point loads under the tires can exceed that number. So it's really important that you think through, how is this mounting system going to be built? Can it be done in such a way where we don't use heavy equipment, or we manage how that equipment is used very carefully so that we don't go over those weight limits? The third is the idea that the load should be widely distributed. So when you think about having the solar array on top of the cap, you don't want to cause more settlement than what's going to occur naturally. So if you have high point loads and you have poorly distributed weight, you're going to have more settlement than you would otherwise have under whatever that heavy object is that's on top of the landfill cap. And then finally, on load limitations, you're looking for a system that's accommodating. As localized settlement occurs, and it will likely occur over the course of time, you're just trying to minimize it when you're selecting the landfill. You want a mounting system that has flexibility to adjust to minor changes in the cap height or localized slope. Obviously, if you have a landfill that settles 20 feet in a given place, there aren't a lot of mounting systems out there that are going to be able to handle that. The second issue that I wanted to talk about in terms of selecting a mounting system is looking at layout and drainage. Landfills have stormwater control systems, monitoring wells, gas collection, a whole bunch of engineering that's built into the cap that you really want to be careful that you don't disturb. So when we think about drainage on the system, there are a couple keys. The first is low point loads. Very similar to what you'd find on a roof, you don't want to put high loads on a given point. Not only do you run the risk of creating settlement that I discussed earlier, but you don't want to create pooling. Because if you create a depression on a landfill, you're going to have a higher likelihood of water pooling. That's going to add even more weight and create issues that exacerbate basically that point load or weight issue. The second is around ground rails. You don't want a situation where you have a continuous grade level projection, because if you do, you're going to impede or potentially impede the natural runoff that's been designed into the landfill. So you want to make sure that water can flow naturally through the drainage that's been designed into the landfill cap, so you don't have water retention on top of the landfill. And then the third piece, and this gets more towards the issues around monitoring wells and venting systems, is you're looking for a system that has flexibility in the layout. You really want to be able to build around obstructions and build around areas that you may not want to be putting solar for whatever reason, due to slopes or other issues. And having some flexibility in system design really helps you accomplish that in real time when you get up there and start building. The third issue I wanted to cover, and really the final issue in terms of selecting a mounting system, is around maintenance. And this is not necessarily maintenance of the mounting system, but rather maintenance of the landfill itself. Landfills tend to require ongoing monitoring and maintenance. So it's critical that you can continue to get access. And that's access to a variety of things, whether it be monitoring wells or just the membrane in general, or being able to get to different areas. You want to make sure that you have the access through the array. The second is one that's not often thought about, but can be critical, and that's disassembly. So if you have either erosion or settlement, you'll often have to go and put additional dirt on top of the cap in order to even things out and prevent there being a situation where there's pooling. In order to do that maintenance, you actually have to be able to get underneath where the modules are, essentially underneath where the racking system is, to be able to perform that. Being able to disassemble the mounting system is actually something that can be critical. And then the third is vegetation maintenance. The vast majority of landfill caps include a vegetative layer. It's really designed to absorb a lot of the rain that will come to the site and prevent it from percolating down through the cap. You have to think about how is that vegetative layer going to be maintained over the course of time underneath the solar system. I've run through very quickly a whole bunch of topics just to give you a high-level view of how to think about selecting a landfill, and then how to think about selecting a mounting system. This is obviously a much more complicated topic than I've had time to go through, but I wanted to give you a little brief overview of some of the highlights. Certainly happy to answer specific questions during the Q&A or outside of this call. When we look at some of the topics we just covered here, they're really very similar. You know, landfills are one of the most difficult places possible to put a mounting system. But a lot of what you use here is really applicable as you think about other applications, brownfields, leach fields, parking lots, whatever it might be. So these are good rules of thumb to think about as you consider some of these other applications. And with that, I'll try to wrap up here and pass on to the next presenter. Thank you.
All right, thank you very much, Seth. I'll just change the slides here. All right, well, thank you so much again. And next we'll be hearing from Jeff and Jeanette at Unirec. Jeff Head is the engineering manager for Unirec's commercial and utility group. He is responsible for the engineering design of PV racking and foundations for projects anywhere from 300 kilowatts up to 20 megawatts or larger. He's a civil and structural project engineer and has been with Unirec for 3 years. Previously, Jeff worked as a structural engineer designing buildings, and Jeanette Brasher is a mechanical engineer in Unirec's commercial and utility group. She is responsible for the engineering design of PV racking for projects greater than 300 kilowatts. She's been with Unirec for 4 years and her previous experience includes PV installations and mechanical engineering roles for electronics manufacturers. Jeanette is also a journeyman electrician. So thanks again to both of you for being with us here today, and please take it away.
Okay, thank you for the introduction. This is Jeff.
And this is Jeanette, and today we're going to talk about how to select the right solar racking system for a utility scale project.
The first question you guys might have out there is, what is a utility scale project? While this might not be the industry standard definition here at UNIRAC, the following three are how we differentiate. First of all, we'll talk about residential and light commercial. That's all projects that are under 300 kilowatts, and these start as small as racking for one module. Next would be commercial scale projects, which are 300 kilowatts and up to 5 megawatts. And then finally, what we'll be discussing is utility scale projects, which are 5 megawatts and larger. Jeanette and I will be talking to you about some of the factors that should be determined when selecting solar racking for a utility-sized project.
So one thing we want to make sure you know is we have numbered these slides, with numbers, but they're not prioritized lists by any stretch of the imagination. They're just basically numbered. And also, we do work for UNIRAC, and we're going to keep this as generic as possible, but some of these photos could have our product in it and stuff like that, but we just wanted to, we'll do the best we can and not say we too much, but we may have to do that.
Please forgive us. You'll hear UNIRAC and we quite a bit, because this is what we live every day. First of all, fixed mount or tracker would be an early question that you should definitely ask. Here at UNIRAC, we do help you with the preliminary design and issuing quotes, but other than that, these decisions go a little bit deeper and get started probably before we get involved in a project. With a solar developer, they're going to ask questions like, what is the power output efficiency calculation? What does that tell them? Depending on the price of land, a fixed ground mount system might be preferred over a tracker. Something that we definitely get involved with early on would be the design loads. Which region the project is in, is there snow, wind, seismic to be considered?
Also, one of the things we have, I just want to show you the difference between a fixed mount or tracker. If you look at the picture to the right, upper right-hand corner there, that's actually a simple single-axis horizontal tracker. And basically what this does is the rows are placed north to south, so the axis will actually be the north to south, and the modules rotate along with the movement of the sun across for the day. So basically those are pretty efficient processes, and they're used quite often in utility projects. The bottom one is a ground mount, and what's nice about a ground mount is sometimes they'd like to use a fixed mount. They can change the angle that they want to do for even production time during the day. They also can change the angle so they can get module density higher. So it's not necessarily just always based on latitude. People can actually do different things based on what they're looking for in the design. So that's basically what you might want to look into a ground mount.
Okay, another topic to consider is total installed cost. The first one here is raw materials. That's easy to figure out what that's about. That's the actual materials, bolts, hardware, beams. That's an easy price to figure. The next one, a little bit more complicated, but that goes into the product fabrication process. Specifically here at UNIRAC for utility scale projects. That's for us a roll forming process for our steel products. That's done in a factory with an assembly line. That process helps us to increase efficiency, reduce the cost, have better quality control, and reduce any errors, and understand what our capacity is, and be able to communicate that with our clients at all times.
Another consideration you should think about when you're doing a utility scale or any project, but utility scale in particular, is the shipping. So depending on where you're located in the mainland, or if this project happen to be going overseas. Overseas is a lot more, there's more complexity to the logistics of it. You have to worry about shipping containers, and the overall lead time can be very extreme on that.
Okay, and then the pictures shown on this slide, those are typical trailers used for our IGM system, and that shows how we try to optimize the shipping, the packaging, try and reduce the number of trailers or trucks needed to ship items to the job site, which in turn reduces the overall cost of shipping for a project. And last on this topic about total installed cost, I want to talk about labor. That's a huge part, especially of large utility scale projects. But material handling, this is done on site. You want to limit the amount of times you touch the material. One thing that helps with this is how is it bundled and shipped to the site, which we just talked about and showed you a couple of pictures. That helps limit the number of times that they're moving material. Another reason that you'd want to avoid moving material all over, other than the time and the labor, is there is a chance to damage parts and pieces whenever you're using forklifts or whatever to move things from side to side of the site. The next thing, very important to us here at UNIRAC, is the parallel process installation procedure. You can see the 4 pictures at the bottom of the slide. The first one shows the pre-panelization process of attaching the panels, the solar panels, to the north-south rails. The next picture shows pile installation being done. The third there shows the skeletal structure, which is our beams being installed to the piles themselves. And the last one goes full circle back to the first picture, which shows those pre-panelized module columns being installed to the skeletal structure and creating the actual tables. The beauty of our system and the way we try to provide it and deliver it to site, design it, everything we do, it centers around this parallel process. Any of these pictures, anything you see in these pictures can be done simultaneously. You can basically hit the site with larger crews, larger number of crews, and have them doing these simultaneously, which helps save a lot of money at the end and get the installer off-site sooner.
One thing you want to take into consideration also is when you're selecting a racking manufacturer is you want to try to get the minimum of field fabrication. So you really want to avoid any drilling, cutting, or welding on site. And some of the reasons to do that would be to reduce any errors, because you're just adding more complexity to the installation process. And also, it reduces the possibility for injury if you're not doing added work. And I know one of the metrics on sites are usually the safety standard, the job site safety standard. So really try to look for the fewest field fabrication when you're looking for a racking manufacturer. Next thing we do is on reliable and repeatable quality racking components. So one of the things that really can be a showstopper on a project, especially an overseas project, is if, because they have longer shipping lead times. So even if a smaller component's missing on these jobs, it can be an absolute showstopper, especially if they're a country that does metric and you're shipping standard hardware to be used. And a lot of sites are very remote, so you can't just go out to a site and say, oh, well, just go pick up some quarter 20 hardware. They don't even know what you're talking about a lot of times. So it's really key to get the right components to the job site all at the same time so that they can start building right away. Because even a small component, such as a bolt or a nut, can stop your project from moving on.
And another thing to look at while selecting a racking manufacturer is check and see if they are ISO certified. The ISO certification, it applies to the processes that create and control products and services, and basically this proves that the manufacturer has demonstrated that they have proper quality control procedures in place.
So another thing that most customers are very interested in is in the warranty. A lot of times they expect about a 20 to 25 year warranty most of the time on a utility size project, and that's because they need to validate their return on investment. So like when they get financing, they will say, hey, so much we're going to get paid off for this much, and then we're going to make so much money. And so that depends also on the life of the product. So they need to pay attention as to who your racking manufacturer is as to the length of the warranty, so that you can get your money's worth out of the project and it doesn't fail.
And racking manufacturers' bankability. With the flood of racking manufacturers that have entered the market over the past few years, bankability is a big deal. Owners want to make sure that that racking manufacturer will be around to honor the warranty, especially like Jeanette mentioned, that those are typically in the 20 to 25 year range. So that's a long time. You got to make sure you can have faith that racking manufacturer will still be around.
The next thing basically I want to talk about today is you want to look for a racking manufacturer that I talked about this a little bit before about installability. Look for the manufacturer that has like innovative designs that reduce the amount of field install that's needed. Again, no welding and drilling on site. And there's a lot of designers out there, so take a look and see who's got some pretty good ideas and who basically is the fastest and easiest to install without having a lot of field work.
And off-the-shelf, one-size-fits-all versus the site-specific design. Basically, off-the-shelf, one-size-fits-all components and pieces are real common in residential and light commercial racking. However, with the size of large utility projects, that's not always the most cost-effective way to do it. Here at Unirack, and there are other racking manufacturers that provide custom designs for each project, each specific site, to better fit the size of the beams and material, maximize and optimize everything to fit the specific site.
And also, there's a lot of site-specific parameters such as topography. Also, as Seth was mentioning, penetrations. Some sites you can't penetrate very well, so you really have to look at that. And it's really a good idea to. Most of the time on utility, they're site-specific. They're very few generic. Also, more eyes on a design also leads to fewer errors. So you might want to look for a racking manufacturer that actually looks for third-party engineering and stamping, so that it's actually being reviewed by others besides just the racking manufacturer. And it's a good idea to get an unbiased review from a third party.
All right. With the increased number of racking manufacturers in the solar industry today, customers should expect to also receive a wide range of services in addition to the racking. Some of those additional services that are offered would be in-house engineering. One example of those is applications engineering, which is what Jeanette and I provide, project by project basis, just backing up the product, designing the product, and being there for any questions, whether it's all the way at the beginning when you're doing preliminary designs and quotes, during the middle when we're down in the nitty-gritty producing construction drawings, and trying to fit our product to that specific site, or even at the end whenever the installers and the contractors are in the field trying to install and they run into bumps in the roads, questions along the way, things that we can do to help optimize the installation. Foundation engineering, which of course goes into preliminary final design of the pile system, which is, as Jeanette mentioned earlier, backed by third-party independent structural engineers. And then site-specific corrosion studies are typically always done to verify what the galvanization is or that coating for those specific materials of the racking in the field. Make sure they can stand the test of time for these long 20 to 25-year warranties that are offered.
Also, you want to make sure when you select a racking company that you make sure the support doesn't stop when the material is delivered on site. It's really good to have field training and support throughout the project. It will ensure long-term success of the project, and it's always good to look and see what additional services the racking manufacturer provides. Depending on the experience level of the project team, it's also very helpful to have a more experienced crew behind them. The racking provider can help out with difficult aspects of the project, even starting topography, the foundation design, just basically everything you can get help from as soon as possible. It will help your project to be more successful. And also just follow through with the delivery and logistics, anything that the racking company can do to help support getting the material there, getting on time, keeping your production schedule, to schedule. Anything they can do to help out is a plus. So be sure you look for those things. The last thing you want to do is have somebody just come and say, well, here's your material and there you go, because that could lead to project failure or extended project timing that could be also a failure. One of the things that we have, sorry, I don't keep meaning to say we, since we do this every day, it's kind of hard, but if you take a look at some of the pictures on the next one on the foundation adaptability, a lot of sites, most of the sites we've seen are not level. And if you look at the picture up in the upper right-hand corner, it shows a pretty steep drop-off going basically from the north and dropping off to the south. So you want to look for manufacturing provider that actually can do those things. Also, if you look at the second picture, this isn't the best picture, but you see this is a slope on the bottom. I know you can't really tell, but it's an east-west slope. And you want to make sure you can match the topography. I would love to have shown you a better picture of matching topography, but you'll have to just kind of envision this. So,
yeah, and I can talk to a little bit more about that. like Jeanette said, there's not too many perfectly flat sites, definitely, and depending on your the customer's preference and the topography of the site, we've had to design tables that can follow the contour whenever the site slopes east to west. Basically, they follow the land and slope with the land. The other option is, and some customers prefer this better, keep those tables flat for as long as possible, side by side, perfectly flat, and then step those down while still keeping the tables level. Once again, that's preference. It's the amount of solar output or power output you're trying to get from your site, and if you can sacrifice spacing your tables in the east-west direction to avoid shading, if not, makes a lot of sense to try and hug the land and follow the contour and install a table that has that slope to try and match the contours of the land.
Yeah, one of the problems with different projects are that it's pretty cost prohibitive sometimes to level some of the hills and the extreme topography you see. So it's always best to have some type of flexibility on the manufacturer that can go both north-south and east-west.
All right, as you can see, there are a lot of factors that should be considered when selecting racking for a solar utility project. We hope we have helped you guys out. Please contact us if you have any questions.
All right, so lots of knowledge to share there. So thank you so much, folks at UNIRAC. Appreciate your time. And we will now move on to Hans here with KB Racking. So Dr. Hans Reinheimer leads the U.S. division of KB Racking. He's been active in the green tech industry since before 2006. Prior to joining KB Racking, Hans was co-CEO of HB Solar of Southern California, where he was responsible for sales and marketing. He's also worked with a startup, Advanced Turbine Designs, founded and ran IE International Corp. And he's also worked as an auditor and a consultant in mergers and acquisitions. Hans earned his doctorate in law. He received his JD from the Supreme Court of Berlin, and he's also studied history and business. So we look forward to hearing that expertise. So go ahead whenever you're ready, Hans. Hey Hans, you can begin whenever you want. Coming in all right?
Yes. Hans, KB Racking. Thanks so much for everyone at Solar Power World for the opportunity to give an overview on how to select the right solar system for rooftop solar mounts. Let's see, I'm trying to use the controls here. Okay, move forward. There we are. Okay. 1 second. Okay. Not this one. There we are. So KB Racking, a little bit about us. We focus on racking specifically. We do ground mounts. We do flat roof. With our partners, Solea, we've done 250 megawatts of ground mounts, pretty much most in Europe. We have done flat roof in North America, company origin in Canada, and we've been putting a lot of systems on sites in the U.S. too. We also do provide racking for pitch roofs, but it's more of a niche market. Why does selecting the right solar racking system matter? First of all, you need to be aware of damages to roof and surrounding. Obviously, you want the system to stay on there. You do want the system to remain intact for the 20+ years that you've calculated the returns for. And also, you need to make sure those panels stay on, stay in shape. You also want to make sure the system is efficient. You want to by the codes. More in California and a couple other states, seismic issues are of matter. And then what most customers look at is purchasing costs and operations and maintenance. Operations and maintenance tends to be rather low on the racking side. But what often is overlooked is the ease of installation, which really directly translates into costs and can far outweigh the impact of higher purchasing costs. So first you need to look at the rooftop. You get pitch roofs, versus flat roofs. By general definition, flat roofs tend to be 5 degrees or smaller angle. Pitched roofs, anything that's above that. But we do need to keep in mind that flat roofs, often within the flat roof, have slopes that are beyond, they're higher than 5 degrees, 12 degrees and more. So often it's a mixed, sometimes it's a mixed systems. On the pitch roof side, there are enormous amount of racking solutions. I'm not going to get into this in detail because it would take me more than the 10-15 minutes we've been allocated. Really, on the main thing is obviously you need to make sure that the system that you acquire is specific to the roof cladding, the roof material. But I think our experience, the main issue is really the quality of installation, and there we can strongly recommend just go by references. Get the best contractors out there, get the ones that do their job right, and then most of the time there aren't too many issues. On the flat roof side, you have two main systems. You have the penetrating systems and the non-penetrating systems. Penetrating systems can cause enormous headaches. It starts at finding the actual joist where you can fasten it. You're talking about leakage issues you're going to have, because water on flat roof tends to stay in the lower parts of the flat roofs for quite a while. Gravity will help water find its way onto the roof if there are any holes in it. And it's just a matter of statistics. A certain percentage of the penetrations will leak after a certain time. The question is not if, but when. So penetrations can also create a false sense of safety, meaning people would think, well, the wind cannot take the systems off, even though because they have been fastened. But that's not necessarily the case. So the issues are, penetration issues are mostly in the existing buildings where you add on the solar system after the fact. But you can also have those issues in non-existing buildings where you integrate the penetrations into the building right away. As to the non-penetrating systems, they're becoming more and more the common standard. These are the ones we're going to discuss mainly. So one of the major things to look at is the weight. You're going to have to find a structural engineer. You have to look at the drawings of the roof, see if you can find anything that tells you what kind of weight capacities you have. And on the racking side, it's probably best to categorize it into a lighter group and the heavier group. The heavier group tend to be the ones that are more ballasted with more concrete or pavers or what it is. The lighter group of racking are the ones that are more refined in their engineering. Probably have more material. There's more engineering. There's more knowledge behind it. So they tend to be more costly. But if your roof cannot withstand 4 pounds or 7 or 8 pounds per square foot, then you're going to have to go with a lighter group of racking systems. Obviously, the heavier group, those rackings tend to be lower cost. So if you look at the roof, first you're going to look at what kind of weight capacities you have, and then you're going to that'll direct you into the group you want to be in. We do have customers that do, even though their roof can withstand more heavier weight, they actually want the lighter systems on there for various reasons. So the next challenge, the major challenge on racking is the wind. Since it's not penetrating, well, how do you keep it on there? And this challenge is bigger for lighter systems, for lighter racking systems. There really isn't. It's hard to speak for all of the U.S. because every state and county is a little different. But to my knowledge, there aren't too many. There's not too much of a code that tells you how it has to be done. But there are U.S. standards, ASCE 7-05, which tell you how to wind tunnel test your system. And you really want to make sure that the racking provider that comes across, and there are many new ones out there, and people in their garage building some racking. You really want to make sure that they have done the testing and done it by an independent external engineering firm. Now this costs money, it costs time, so it really weeds out the serious companies from the ones that are just sort of doing something on the fly. And obviously in Canada, they're under standards, and best is if it applies to both. That's even better. So, third-party testing is structural, but in the end, the ones that are going to say is the racking okay or not is a structural engineer. This is the structural engineer that will, approve the solar system on your roof. They're going to look at the weight, also the wind requirements, and we work very closely, even though they're independent, but we work very closely with the structural engineers that our clients working with, because we need to put them up to speed as to understanding, making them understand how the system works, why it works, and wind. The structural engineering is not as common as one might think. Most structural engineers don't deal with wind, so we guide them through the process, and some are faster, some are slower, but we haven't had a case where the structural engineer wouldn't stamp the specific configuration on the roof with our racking. This is also helpful if you go by the standards. It makes it easier for them to see that this racking is for real. Here's some other questions that's come up. Seismic, I've just this morning at 3, there was an almost 3.8 earthquake in California here, just a couple miles from where I live. So we keep reminded about this in California. From the non-California, sorry if we bring it up here. The seismic topic has really been looked at more and more closely by the counties and the approval agencies since Fukushima. Before that, it was sort of things just sort of slipped through more. They're less concerned about it, and it has Fukushima. What we've seen there has really moved the counties to say, well, we want some kind of fastening. We want this roof, even though it's a non-penetrating roof, we want it to be connected to the roof at some point, or a few points, just to make sure it doesn't slide off the roof in case of an earthquake. Now, we're dealing with a lot of engineers, specialists that have for years done studies in earthquakes, and some of us tell us, well, an earthquake shakes one way and then the other, so the system that's on there, even though it's sitting on there, is not going to be jolted like something that in a car that when you hit a wall would get jolted forward. Earthquake moves back and forth and back and forth, and typically, in my understanding, the building goes before the racking falls down. But nonetheless, there's been a lot of discussions in this field. The Structural Engineers Association of California, they've been looking at it, and so we're closely monitoring it. For now, there's not one binding set of laws. So it ends up that a system then has maybe 20 penetrations. They need some flexibility. We do have a list of penetration recommend. I didn't want to put it out here because we don't want to endorse a specific product, but if you have any questions, just feel free to send me an email. Send us an email at the lower right. You can see the email. You can just send us a question, what we recommend, and we can guide you what penetrations, fastening hardware we've had good experience with. UL 2703, non-binding. It's not required in most situations, but more and more companies have been moving into it, and I think it's going to be the standard in the next couple of years. Installation time, and this is really the dark area where we see a lot of things, a lot of statements on websites of other companies that claim that you can install so many kilowatts in so many hours. And I look at these numbers and I go like, yes. So this is really the area that's hard to see and hard to predict. First of all, most installations have some point of custom element to it, but every site is different, and every team is different, and. So in our experiences, we go try out the system. If you have multiple projects, try it out with one company and see how it goes. Really question the numbers that you see on the websites, on any website, including ours, on installation time, and really think, is this real? Are these numbers just pure marketing numbers and make someone look good? So this is sort of the last point. Installation time is really the crucial point. Just that'll save you money. It'll get your teams through the site faster, enable you to put on more roofs, more systems in a given time. So yeah, this is it for now. I appreciate the opportunity. I think we're now at the question area. Feel free to email anything. Be happy to answer any question I can or guide you to the right people within our company. Thank you.
All right, thank you so much, Hans. Well, now, as Hans said, we'll begin our question and answer session. I got a lot of questions that were submitted during the presentation, so we'll begin asking those. Remember, you can continue to submit your questions at any time in the GoTo meeting panel on your right. So let's circle back with Seth, because he's been nice and quiet there for a while since the beginning, so I'm sure he's dying to answer a question. So Seth, someone is wondering where they can find landfill sites, if there's a list or some kind of standard reports somewhere at the city, county, federal level that someone can find this information?
That's a great question. At the federal level, the EPA has materials that are available in regards to regulatory compliant closed landfills. I can't point you to the website at the moment because I just don't remember off the top of my head. But feel free, whoever has the question, to email me, and I will try to send you a link to that. In terms of what's available on a local level, I can't speak to jurisdiction by jurisdiction whether or not you can get a hold of that information. It tends not to be that publicly available as far as I'm aware, but others, I don't know if anyone from Unirac or KB Racking has any knowledge on what locally may be available.
If no one has any further comment on that, I'll actually move on to Jeff and Jeanette at Unirac.
We are here.
Wondering. Okay. Are you ready for the next question, or did you want to add to the previous one?
No, go ahead. We're ready.
Okay, all right. So given the price of panels, someone's wondering how feasible is tracking? Is it not more feasible to add panels and then to add the cost of trackers?
Yeah, that's a good question. We typically don't get involved with that much. Like I said, people come with projects, come to us, and we provide racking for them. As far as developing the project and understanding the module count that fits on a specific site and whether it's tracking or fixed, that usually is a decision that's made by solar developers that are looking for a racking solution and then come to us. So we can try and follow up and answer that question via email when we get a little bit more information from a solar developer, but that may not be a place that we can answer that.
All right, fair enough. This question's for Hans. Hans, can non-penetrating systems work in hurricane-prone areas or probably areas with any kind of, harsh winds and things like that? Hans, are you having a little trouble coming in here? All right, we'll give him a moment. He may be having some audio problems. Seth, I have another question for you. Someone's wondering if you are able to speak on PG&E's position on landfill solar farms or maybe any utility, because this particular person's company has experienced some reluctance for PG&E to accept larger solar farms, particularly in the North Bay area. They're requiring a lot of justification on why it's needed, and I don't know if that's a common thing among other situations as well. Can you speak on that at all?
I'll speak only to say the following. I obviously can't comment on a specific case. I'm not even. I may have actual knowledge on this one, and having left the company, it's not appropriate for me to comment on that one. But in general, I think you have the same set of issues. California is a particularly difficult place to do a landfill PV project, both in terms of the utilities as well as the number of parties from the local air board to others that need to be consulted. So it's really hard to get one done here. I don't want to speak for a company that I no longer work for in terms of what their policy is relative to a given project. I can, Kathy, comment on the previous question, unless Hans is back online.
Yes, I'm back online. Thanks.
Okay. All right, go ahead, Hans.
Thanks. So the question was on whether non-penetrating racking can be used in high wind zones, and the answer is yes. Our systems go up to 140 miles an hour. Anything above that, you're talking about flying through the wind, probably damaging the panels. So putting solar in hurricane areas is, it's a question. Once you have a hurricane going through and a coconut flying around, you're going to have some damages. But yes, you can do 140 miles an hour winds with our system.
Seth, did you want to comment on that as well? Do you have anything to add?
Yeah, I think I broadly echo what Hans is saying, that really what you can do in any given area is you're going to take a look at the 3-second gust max for that particular area. So there are lots of hurricane areas on the eastern seaboard where the max wind speed you see over the 3-second gust is 115, 125 miles an hour, up to 140. I had someone ask me the other day, what happens if a tornado hits a system? And my comment back was, if the roof's not there and the building's gone, I can't comment on where the racking system's going to be. So, there's a limit to what makes sense with a ballasted system. When you start getting up into the, let's call it 180 mile an hour wind zones that you'll see in some of the tropical areas for that 3-second gust, you're going to really look at either a penetrating system or determine whether or not it's appropriate to put a system there at all. I think often you'll find that you can still put a system even if there's likely to be debris on a high building or building with parapets. You're going to look specifically at the case to determine what you want to do.
Thanks. And maybe I can add, this is Hans. In the hurricane season, my mom lives in Florida, so the people prepare for hurricanes. If you know a big one is coming, you may consider putting the panels down, because they may not fly off, but something may hit them. So that's another option. But with anything above 115 or 140 miles an hour is really rare.
All right. This next question is for Jeff and Jeanette. They're wondering, is the panel install process offered by UNIRAC or typically done by an independent EPC? Probably an independent EPC, is that correct? Or
that is correct, but we do kind of help to plan that pre-panelization process. We like to hit the job site and get people started in the field, make sure all the questions are answered, give them a good kickstart during installation, and we can share pictures and lessons learned. We try not to get into the means and methods of the installation. We leave that up to the EPC or the installer. But yeah, we definitely help anywhere we can with, like I said, lessons learned about pre-panelization and what has worked for others on specific job sites.
all right, here's kind of a case study, and anyone can answer this, whoever is able to do so. This person is saying, in Mexico, we have flat concrete roofs with high parameter walls. To avoid shadows, we need to elevate racking with relatively high standoffs. This leads us to mount horizontally. Are there any feasible standoff solutions, assuming non-penetrating systems, horizontal mounts, with up to 1 meter standoff or elevation? So does anyone have a comment on that?
Well, this is Hans. We wouldn't, in this case, we wouldn't use our ground mount. We would use we wouldn't use our flat roof systems because they need to be flat. We would use our ground mount. And I know in Mexico, typically they have concrete roofs, so it makes it easier to connect it to the roof. So we could, there are ways to do that. You're probably looking at ground mount, not the typical flat roof systems.
Yeah, I'd echo Hans' comments. When we look at things that you're looking for a meter of clearance and that type of application, we'd use a ballasted ground mount product. Like we have a low profile ground mount product that's ballasted, so we would just put that up on a concrete roof to give you the height that you're looking for.
All right, and I think we have time for about one more here. I thought this was a pretty interesting question. Typically, what percent or fraction of a utility scale system is due to racking? And has the cost per watt of racking seen the same cost reduction as panels? Or if you don't want to go cost per route or cost per watt, what's the cost contribution for a given specific yield in kilowatt hours, kilowatts over the life of the system? But I thought it was interesting to ask if, racking has come down. Obviously, there's a panel oversupply, but does anyone have any comments on that at all?
Yeah, this is Jeff, and I'll talk. I can't go specifically on what percentage racking contributes to a utility scale project, but I do know that, and everybody knows that the price of panels has come down over the past several years. What I heard, and not sure what kind of facts there are to back this up, but it kind of makes sense as far as the overhead, the amount of margin that was added into panels. I mean, they have the ability to keep fighting to the bottom and get down. Racking was always a little bit more closely competitive as far as margins. So racking has got more competitive, but you're not noticing it as much as you notice from a panel-to-panel basis, just because that's almost a race to the bottom. Everybody's had to tighten up their system to be more competitive, to be able to sell all across the board, all components and parts and pieces to solar.
All right.
This is can I
I'll
just add on for a second? I think we have seen substantial declines in total racking costs, both in terms of the capital investment as well as you look at installation times and some of the other associated costs over the last, let's call it 4 years. And when you look at the module declines, they're astronomical. But I think you've seen racking declines of, maybe 50% over the all-in cost over that period. In particular, you look at things that not only do you have just more efficient designs and designs that are really helping you have less material as well as install quicker, but you also have things like UL 2703. And 2703, if you get the full listing, allows you to electrically bond and ground your modules and your array without running copper wire to everything and without putting ground lugs on everything. It basically says, listen, the system itself provides that electric bonding and grounding, ground one module for every 100. And depending on the market you're in, that can be worth 2 to 6 cents a watt. And that's a substantial decline when you consider what overall racking costs can be. So even though the racking has come down a proportion, when you think about things like that, that's very large declines in the overall cost to actually deploy a system out in the field.
Thanks. And this is Hans. I absolutely agree. It is racking is going to go down further, but we're getting closer to material costs, and you do need material for it. And then what it comes down to is installation time. That's the topic of it. And you really need to look at how many components, how many screws, how many, and so on and so forth. How much stuff do you have to put on the roof? How much stuff do you have to figure out, sort? Those are the things that are going to matter in the future for racking. It will not come down, the price will not come down like the panels did in the last few years, but that's for other reasons. But it will come down somewhat more, but really, if you're looking at purely the price of the racking, you may pay 5 cents more and save 20 cents on the on installation. Well, that's a no-brainer. So that's what you're going to have to look at. And unfortunately, there's no easy tool for that. You're going to really have to dig in. You really have to push aside the marketing stuff you see from every company. I'm talking about every company. You really look in how many parts, how easy to install it, look at their videos, talk to installers, and really get a feel for it. And ideally, try it out. Try a couple out and see how it goes.
Yeah, I think one of the important things is also not just upfront cost installation, but you also need to look at safety and reliability. And these systems are going to be up there for 30 years. You need to look at the total life cycle cost of the product. How are you going to maintain the system, maintain the roof? What's it look like at decommissioning, the whole 9 yards? Because once you start thinking in a more sophisticated manner about the whole process, you can really start to determine where your best dollar is spent up front.
All right. Well, if no one else has anything else to comment on that question, I think that we'll end things here for today. But thank you to the audience so much for all your wonderful questions. That really makes this a great presentation, and for listening. And I'd like to also thank all of our presenters for being here to share their expertise with us. We really appreciate it. It's been a great conversation. So I hope that everyone enjoyed it, and please join us for future Solar Power World webinars. There's lots more to come. Thanks so much, everyone.
Thank you.
Thank you.